Good morning. We are now on lesson 3, day 2. And again, if you did not communicate with me about any of your questions yesterday, please make sure you do so. So today we're going to be using the packet from eMath Instructions. So I'm going to have my little lesson up. I'll also give you the author's lesson as a different perspective. But you'll notice on this lesson, we go straight into Venn diagrams and two-way tables. And I think that if I would have went right to this lesson without a day of just Venn diagrams and two-way tables, you might have had some troubles. Hopefully now you'll be fine. So now today, this is lesson 3, day 2. And this is all about probabilities with the Venn diagram, the two-way tables, but the overall name of this is adding probabilities. So this is lesson 3, day 2, adding probabilities. And we are using Venn diagrams and the two-way table. Okay, now if you notice in the middle of the page, they give us the definitions that we had started with when we started yesterday. So I'm not going to write them again. They're there for you. Please make sure you use them. And let's move quickly through this. Exercise 1, consider this spinner has been divided into 8 equal sectors. And the spinner is only spun once, and A is the event of landing on an even. So A is my set of even numbers, and the even numbers from this spinner are 2, 4, 6, and 8. That's my subset. And B is the event of landing on a prime number. So B, these are my primes. Now, guys, remember, 2 is the only even prime number. So 2 is prime, 3 is prime, 5 is prime, and 7 is prime. Now there's a great debate on whether or not 1 is prime. I'm from the school of thought that 1 is not prime because it's the definition of prime, so I am not calling 1 a prime number. So if I were to then make a Venn diagram of this, the spinner is the universal set. So the spinner has 8 items on it. And my first part, A, are my even numbers. So I am using 2, 4, 6, and 8. But then they say, okay, now let's put on set B, which are my even numbers. Well, this 2 now, my prime numbers, these are my evens. My 2 is still an even, but he's got to jump over to here with set B, where I have my prime, because 2 is both even and prime, and then I have my 3, my 5, and my 7. So that leaves me with neither being my 1. There's 1 is neither even nor is it prime. So if I then follow the formulas for this, they say write out the following sets. I want set A being A or B. So now I want to write out the set of A or B. Well, if I am in set A or B, I am 2, I'm 3, I'm 4, I'm 5, I'm 6, and I'm 7. Lastly, 8. And if I'm A and B, I'm just 2. Now, from exercise 2, why is the equation, the number of items in A or B, equal to just a number in A plus a number in B generally not true? Well, if I took the number in A or B, and I called that the number of A items plus the number of B items, I would have had in A, there were 1, 2, 3, 4, 5, 6, 7 items. And then the number in B, there was 1 item, and that equals 8 items. And you might say, okay, well, that makes sense. But if I look at the picture, I have 1, 2, 3, 4, 5, 6, 7 items. And that's because the 2 was counted twice. So this is why this will not work, because here we counted the element 2 twice, and we can't do that. We can only count it once. So therefore, if I want a true statement, I would have in the number in A or B, which I probably should put parentheses, is going to equal the number in set A plus the number in set B minus the number in A or, and B. So now this was my evens, 1, 2, 3, 4. And this was my primes, 1, 2, 3, 4. And my overlap was 2. And there are my 7 elements, which I should have had. In my OR, I should have had the 7 elements. 1 was the only guy that was neither. All right, so that was first page, and hopefully that went a lot faster. Now, if you look on the next page, they're adding in a two-way table, and this is all about seniors at a very small high school, who's going to college, who's not going to college, who's male, who's female. So we're splitting down this demographic of college, not college, male, female, and it's all about these 52 seniors. So the universal set (52 seniors). Now picture this. Picture they put only the seniors in the auditorium. And so all of them are in the auditorium, and they want to start getting some numbers. So, you know, maybe one of the APs or maybe one of the guidance counselors asks, okay, stand up if you're going to college. And we find that going to college, 29 people stood up. So let me just... 29 kids are going to college. Now, if there's only 52 kids in this school, then that means anybody with, you know, a calculator or even thinking it through are going to say, okay, not going to college would be 52 minus 29, 23%. And here's my totals. So this would be all about who stands up going to college and who stands up not going to college. Then we have to say, okay, now they want us to split this into male and female. So they go back and they say, all right, if you're going to college and you're male, stand up. So they say, okay, 16 boys stood up. That meant if 29 stood up first and only 16 of them standing are boys, the other 13 had to be girls. And then the next line would be saying, Now they say, okay, the 29 that stood up going to college, sit down, I want to see the other 23. So now 23 people are standing up. And they say, okay, if you're a girl, sit down. That left 14 boys standing because 9 girls had sat down. So what overall is going on here? There are 30 boys in this graduating class and 22 girls in this graduating class. And out of the 30 boys and 22 girls, they're either going to be going to college or not going to college. So they want, if you notice when they have an N, that means number. You can use the hashtag symbol for number, or you can use the N for number. So for part A, or part 1, the number of males going to this school, we have 30 males. And then they want the number of females, and that told us there were 22 females. Then they want the number of kids going to college, and the number of kids going to college was 29. Then the number of kids not going to college, and that was 23. Then they want the number of males and college. So now this is an overlap. The number of being a male and going to college. Well, that's right here. Male and college, like again, plotting a point on a graph, that's 16. Then they want the number of females in college. Well, again, going to college, female, 13. And then they want female or college. Well, now if I want to be female or college, so now we're an or statement. This is the number of females plus the number of college, and then we have to minus the number of females and college. So we have to pay real close attention to the grammar. So for this last one, the number of females were 22 females, and then the number of kids going to college was 29. And now we have to subtract the overlap of females going to college, which is 13. And so when we do this, we end up with, this makes 38. Well, no, do too fast. This makes 51 minus 13, 38 are female or going to college. So this would be like if they said, okay, all the girls stand up, and then every girl in the auditorium stood up, and then they said, okay, if you are not already standing, which means you're a boy and you're sitting, stand up if you're going to college. And then the 13 stood up. So the 22 and the 13 made the 38. I can't talk and write at the same time. Made my 38 students who are female or going to college. So now they want the probabilities. Now this is when you have to really, really read the question carefully. What is the probability that a person picked at random? Now random means we're using the entire group. That means this is the full sample space. Would represent a female who's going to college. So now the probability of being female and college, and now we're not going from a number. A number is simply that, a number. Now I'm a probability. So now I'm a fraction. Female and going to college was 13 out of 52. Now you could reduce this to 1/4, but again, this answer is perfect, and I would actually keep it that way. C, what is the probability that a person picked at random would be a female or somebody going to college? Okay, so now if I want the probability that the person would be female, so now the probability of female, and now it's or going to college. Well, again, female is 22. Going to college is 29. Minusing the overlap of female and, so like think about it. Here you had to go across to get to 29, you had to go down to get to 22. This was the overlap minus the 13, and this is all out of the 52, because now it's asking you for a probability. So this now becomes 38 out of 52. Again, don't bother with reducing. Explain why the probability of being female plus the probability of college is not the same as female or college, and that would be because you counted these 13 people twice. You counted them going this way, you counted them going this way. These guys were counted twice, and that's what you would want to say for part D. And then part E says the general probability law then, again, would be the formula. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So they wanted you to just rewrite that definition. So I'm hoping very much that today makes a lot more sense than it would have if I didn't do yesterday, and slow down on these packets with you. But again, if you're not following and you don't contact me, I can't help you, so please contact me if you're not following what I'm doing. And so we have one more problem on this classwork, and then you guys have your homework to do. Number 5 says a standard 6-sided die is rolled once. So your sample space for a 6-sided die would be 1, 2, 3, 4, 5, 6. I always write out my sample space if I can. And I gotta have a marker that actually works. So let's try this one. So my sample space is 1, 2, 3, 4, 5, and 6. And it says, find the probability that a number rolled was either even or a multiple of 3. So now I want the probability of being even or a multiple of 3. Okay. Well, how many even numbers do I have? I have an even, and an even. I have 3 even numbers. And multiples of 3. 3 times 1 is 3. 3 times 2 is 6. I have 2 multiples of 3. The 6 has a check and an underline. That's my overlap, minus my 1 overlap, all out of 6. So 5 minus 1, this probability is 4 out of 6. So if I know my formula, I can do this work pretty quickly, because again, this was equal to the probability of being just even. That was my 3. 3 numbers were even, plus my probability of being a multiple of 3, and that was my 2, because 3 times 1, 6 times 2, 3 times 2, and then minus my probability of even and multiple of 3. And so there you go. I had 3 out of 6 plus 2 out of 6 minus 1 out of 6. Since they all have the same denominator of 6, I just kept it. You could have written it as 3 out of 6 if it makes you happy. You're still going to get to 4 out of 6. So you can either keep the common denominator if you see that, or you can write them individually. Either way is fine. And then lastly, part B. Then they say that was 5 rather. Now lastly, number 6. Insurance companies typically try to sell many different policies to the same customer. At one such company, 56% of the customers have their car insurance. So now this is problem number 6. So car insurance equals 56%. And then they say 48% have homeowners, so home insurance is your 48%. And then they say 18% have both. All right, so there's the setup. Car insurance, homeowners insurance, and both. And now they want to know, what's the probability that you have at least one policy? Well, the probability of at least one policy means the probability that you have car insurance or you have homeowners insurance, but then we have to subtract out the people that have both car and home. So car insurance was 56%, and then my 48%. So you add these up, you're bigger than 100%. That can't happen. Minus your overlap of 18%. This gives us a value of 86%. 86% have homeowners insurance, car insurance, or both. And, you know, other insurances could be a lot of other things. Jewelry, you know, you have motorcycle or other things like that. And then find the probability that she or he has neither of these policies. All right, so if 86% have at least one, how many, the probability of having neither? So again, maybe you have jewelry insurance, I don't know. That would be the one whole, the 100% minus the 86%, and then that would be 14% have neither. Okay, so give the next 2 pages of this packet a try. Let me know right away if you're having any trouble.